So just to continue with our functions, sometimes functions are given with different parts to the domain. So rather than just saying that it's going to be the same function for the whole domain, there are split into pieces basically. So sometimes we have functions that have been split. So sometimes functions are defined in, I'm going to call them pieces. And what will happen is that each of these pieces will have a different function. And for different pieces or parts of the domain, we'll have different functions that we want to draw. So, for example, we might have something like this. So I'm going to have a function of x equals, I'm going to make it into a curly bracket. So I'm going to say the function of x equals 4 in between -4 and 2. It equals -2. Oh, sorry, it doesn't. It equals x squared in between -2 and 2. And it equals 8 minus 2x in between 2 and 4. So if I wanted to draw this function, or to think about what it looked like, I'm going to have 3 different parts to my picture. I'm going to have to think of each of these separately. If I draw a quick sketch of an axis. Okay, so here's my axis drawn then. And I've gone from -4 to 4 on the x-axis. In fact, I've gone to 5. And I've gone up to 5 on the y-axis. So between -4 and -2. So what that's saying is between here and here, so this section of the graph, I'm going to draw this function where fx equals 4. Fx is just the y, isn't it? So, in fact, I've labelled this y. I could have labelled that f of x, couldn't I? So let's just put that as f of x. So, f of x equals 4, or y equals 4. Between -4 and 2, we know that that is just going to be a straight line. So that one's just going to be a horizontal line going across to there. Then it says between -2 and 2, so that's from here to here, I'm going to have the function x squared. So -2 squared is 4, so I'm going to be starting at the same point. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And we should know what this graph looks like. It's going through that point we've said, that point, and back up to here, that point, isn't it? So this is just a parabola. It's not a very neat parabola, but nope. It's going to come down, tail off the bottom, go back up to there. So that's that second bit. I've now done this second piece of my function. And the last piece, well, I know this is going to be a straight line. It's a linear 8 minus 2x, with a gradient of -2, y-intercept of 8. But if we just plot some points, when x is 2, if I put 2 in there, 2 x's are 4, 8 minus 4 is 4. So I'm starting where that one ended. If I put 3 in, 2 3s are 6, 8 minus 6 is 2. That one goes through 2. If I put 4 in there, 2 times 4 is 8, 8 minus 8 is 0. So this one should be a nice straight line, straight down like that. And that's my function. I'm only looking at a domain that's going between -4 and 4. So I'm only going between -4 and 4 in the domain. If the question asks me for the range of this piecewise function, the range is the y. So the range of this would be that fx, or y, is going between 0 is the lowest it goes and 4 is the highest it goes. And the range we said was from -4 to 4. If you're happy with that, I suggest that you have a look at the functions sheet I gave you with the questions on it. We did some of them for prep last lesson, and I think the exercise we're looking for is exercise 4 on these piecewise functions. Have a look at those and I will post some answers up a little bit later.